Once the technical characteristics of pumping are determined during hydraulic dimensioning, it is necessary to select pumps which are adapted both to the site and to the water management department's required operating mode. So how do we go about this? To begin with, we're going to see how to select the correct pump and analyze its characteristics. When choosing a pump, it is essential to know the operating flow and the TDH required to transport water along the length of the discharge pipe. Pump suppliers possess summary graphs presenting the global flow, TDH operating ranges for several technical variants of a same pump model. On this graph, the TDH is placed on the y-axis and the flow on the x-axis. On this graph, in the case of pump variations, the operating ranges are represented by polygons. Consequently, in the following example, according to the supplier, the pump referenced 32.2.1 can be used to operate on a chosen operating point on a flow rate of between 1.2 and 12.0 meters cubed per hour and a TDH scale of between 7 and 80 meters of water column. This graph therefore allows us to quickly identify which technical variant of a model is best suited to the needs of the pumping site. Once the correct pump has been selected, we can access its detailed hydraulic characteristics, which are available in a specific graph. This specific graph is generally composed of 4 different graphs, where the flow is always situated on the x-axis. It includes the TDH curve, the pump's hydraulic performance curve, the power consumption at the pump shaft curve, the NPSH required curve. It must be noted that sometimes the graph curves are completely or partially compiled within a single graph. Curves can also be provided for various impeller sizes. It is essential to note that in the case of a multicellular pump or a multi-stage pump, the graph provided generally corresponds to the performance of a single pump bearing. Let's take the example of a graph where the TDH and pump performance are jointly represented according to the flow for 2 different impeller diameters. The upper curve concerns a pump impeller with a diameter of 337 millimeters, and the lower curve a pump impeller with a diameter of 303 millimeters. The labeled and figured values on the 2 curves represent the hydraulic performance of the pump at the flow and TDH considered. For example, if water is pumped at 600 meters cubed per hour and a TDH of 130 meters of water column, using the pump whose impeller measures 337 millimeters, the hydraulic performance of the pump is 82%. Once the performance is identified, it is necessary to check whether the NPSH required is lower than the NPSH available. The NPSH required is defined by the manufacturer on a graph which is traced according to the flow. In our example, at 600 meters cubed per hour, the NPSH required by the pump is 8 meters of water column. Lastly, it is necessary to define the power consumption at the pump shaft. This data is also determined thanks to a curve provided by the supplier. The pump with an impeller measuring 337 millimeters and discharging 600 meters cubed per hour consumes 250 kilowatts of energy. These curves are valid for a given motor rotation speed and are established for an electricity supply frequency of 50 Hz or 60 Hz, depending on the country of use. Pump curve graphs are often available on supplier websites, which are equipped with freely accessible platforms to help determine the best suited pump according to the dimensioning parameters provided. So let's go over the main points again. To select a pump adapted to the pumping site, Thanks to supplier curve graphs, it is necessary to know the desired TDH and operating flow. It is then necessary to refer to the various general and specific curves given by the supplier to determine the best suited pump model, and namely, pump impeller diameter, whether single or multicellular, hydraulic performance, power consumption at the pump shaft, the NPSH required.